Hey guys, this is Coach Lowe, and we are going to talk about some angles and parallel lines. So this is Geometry 3-2, angles and parallel lines. So in the last section, we talked a little bit about when I have two lines and they're cut by a transversal and they don't necessarily have to be parallel. This time we are going to talk about the special thing that happens when lines are parallel. So it's like math magic. Woo! All right, so let's go ahead and sketch a couple of parallel lines here. And a transversal. So I have parallel lines cut by a transversal. My parallel lines are L and M. Lines L and M are parallel to each other. I'll go ahead and mark it. Remember from yesterday how we can mark those lines. And then my transversal I'll go ahead and call T. Doesn't have to be those letters, but we'll roll with that. When I have a transversal that cuts through lines, with each line that it intersects, I have 4 angles, and so I'm going to go ahead and number those. Now, a special thing happens with parallel lines. We have corresponding angles. So remember, we talked about corresponding angles. There, if I pick up this group of 4 and land it right on this group of 4, corresponding angles are landing in the same spot. So they're in the same spot of the transversal and the parallel line. And so like angles 2 and 6 would be corresponding angles. Corresponding angles are congruent. Corresponding angles are congruent when we are dealing with parallel lines cut by transversal. Now we saw that that's not always true with lines that aren't parallel, but with parallel lines you can see if I pick these 4 up and put them right here, they're going to be exactly the same size. So corresponding angles are congruent. Go ahead and pick out the other pairs for me. So unpause the video, I guess you probably did here, so hopefully, or else you can't hear me talking. So angle 3 and 7, you should also have angles 1 and 5, and you should also have angles 4 and 8. Those are corresponding angles. There's some other angles that you know that are congruent to each other. So think about what other things you know about these angles. You also know vertical angles. Let's do those first. Vertical angles. Vertical angles are congruent. So we have 2 and 4. 2 is congruent to 4. We have 1 is congruent to 3, and then we can do the other sets. Angle 6 is congruent to angle 8, vertical angles. Angle 5 congruent to angle 7. Remember, vertical angles don't share any sides in common, just they meet at the vertex. Vertical angles, 2 lines intersecting, those ones that are across from each other. All right, another set that we can look at, alternate interior angles, and this is theorem 3-1. Alternate interior angles, so remember interior, inside the parallel lines, and we're going to alternate the transversal. So alternate interior. All right, so alternate interior, 3 and 5. Angle 3 and angle 5. All right, those are congruent to each other. So if I have 2 parallel lines that are cut by a transversal, then alternate interior angles are congruent to each other. So angle 3 is congruent to angle 5. Angle 4 is congruent to angle 6. All right, now think about that. If I pick these 4 up just back to our corresponding angles and stick them right here, 3 would be in 7 spot. So 3 and 7 are equal, which means 3 and 5 are also equal because they're vertical angles. So kind of a cool thing. And then the other set of alternate interior angles would be 4 and 6. So angle 4 is congruent to angle 6. All right, consecutive interior angles. They are supplementary. Consecutive interior angles. So we're staying on the inside. Consecutive interior means same side on the inside. Same side on the inside. They add to be 180. They're supplementary. So consecutive interior, same side. Remember we talked about that. Those are same side of the transversal. So angle 4 and angle 5 are supplementary. That also means the measure of angle 4 plus a measure of angle 5 adds to be 180. All right, 2 more, 3 and 6 would also be supplementary angles. All right, so that is theorem 3-2. Consecutive interior angles are supplementary. All right, theorem 3-3, alternate exterior angles are congruent. Alternate exterior angles. All right, so where would that be? So we're going to alternate the transversal and we're exterior, we're outside the yellow. So how about 2 and 8? flipping from from the right side of the transversal to the left side. So I'm talking about T, flipping sides, and then staying on the outside. So alternate exterior. Alternate exterior. Angle 2 is congruent to angle 8. Angle 1 is congruent to angle 7. Alternate exterior angles are congruent. All right, we will practice a ton on those, but you need to make sure that you understand where those angles are and when they're congruent and when they're supplementary. Now, we also have another thing that we've talked about a lot. We have linear pairs here. So 1 and 2 are a linear pair, 2 and 3, 3 and 4, 4 and 1, and we could do the same thing with the other set. So the cool thing that happens with this, and you'll see this as we work some examples, is if I give you one measure, so if I tell you angle 1 is 47 degrees, you can find every other angle on here. Because first of all, you already know these 4 in this set, because you know vertical angles are congruent. You know these two guys are a linear pair, so angle 2 is 180 minus 47, which makes it 133. That makes this one 133. I know that alternate interior angles are congruent. That makes this one 133. That makes this one 47 because they're a linear pair, and I don't know why I wrote 45, just to make sure you're watching, I guess. Then I have vertical angles and vertical or linear pair, either one. So bam, give me one of them. We can do all of them. All right. See you guys soon. This is Coach Lowe, and I'm out.